response time problem. What does that usually mean? So that's skewing. Skewing can happen. Another thing that can happen is that the distinctions on the scale of likelihood ratings or impact ratings are not well defined or not well internalized. So we want to check to see if that's happened, and it's very easy to do when you've captured these risk items and their ratings in a spreadsheet, because you can create a histogram like this guy here. And basically what we have in this histogram is with the number of risk items associated with each rating. So we have, looks like about 2 risk items that had a risk priority number of 1. And it looks like we've got 6 that had a risk priority number of 15, and we've got 4 that had a risk priority number of 16, and so forth. So we can see here that there's a bunch of risks that have a risk priority number of 6. And that's kind of a problem, because what you really want in this distribution is something, you want something that is normal-ish. Now, I say normal-ish because you're never going to get this precisely normal. By normal, I'm referring to a bell curve or normal curve or Gaussian distribution, whatever name you learned for this in college, but it's the bell curve. And you want to have your histogram look more or less normal. Now, don't get too bogged down in the details of, oh, it's not perfectly normal, so I got to go tweak some values and tweak some values. No, that's not what I'm saying here. What I'm saying is, if you see gross deviations from a normal distribution, as we see here, then it's probably a good idea to, not probably a good idea, it is a good idea to go through and try to figure out why the clumping is happening. So here we've seen clumping, and specifically a form of skewing. That's the ratings are skewed to the more risky side of the scale, which is a concern. Now, what we do when you see that is that you look at the number of risk items that have particular likelihood ratings and the number of risk items that have particular impact ratings, and you want to try to identify where the skewing comes from and where the problem is. Now, at first, if you look at the left-hand side here, which shows the number of risk items at the particular likelihood counts, that almost looks like there's a problem here. Particularly, you get it down here, and you go, wow, it really does seem to be pretty heavily skewed towards the less risky end of the scale. But this is a mature, well-established product. It's got a maintainable, solid code base, very experienced developers. So this is actually the likelihood distribution that you would expect for a product like this. Where the problem comes in is in the right table. You notice that fully half of the impact ratings are right here at 2, impact of 2, or in other words, high impact. And that's problematic under any case. Now, it's possible that there's something fundamental about the application that tends to skew the impacts towards the higher end of the scale too. But the bigger issue is, if that were the case, you'd expect that you see the kind of distribution that we see over on the likelihood side. But certainly you don't want all 50% of the risk items to have the same impact rating. That's a clumping issue where you have a problem with this distinguishing between the impact ratings, in this case of 2 and 3. So we fixed that. We changed the definitions of what the ratings were for 2 and 3, what that implied from an impact point of view, and you can see these precise definitions and the changes we made in the article, as I said, that's on the website, the risk-based testing article. But this is now the adjusted risk priority number histogram based on that reevaluation. And as you can see, this is closer to a normal curve. So it was a pretty simple problem to fix. Just change the definitions, go through and look at some of the 2s and see if they would actually fall into the 3 categories, and reconfirm with the stakeholders that those changes were okay. And that turned out to solve the problem. And here you can see, I just had a transition there you should have caught that showed that changing from the old distribution to the new distribution, where you can really clearly see the distinction between the two and why this repaired distribution is better. I'll run that animation here again in case you didn't catch it. You can see that the revised distribution is clearly much more normal. Okay, so now at this point we've got a solid quality risk analysis document, and it's a good basis for testing. So at this point, Test Manager is going off to align the testing with risk. So one of the things that he did was he goes through the risk items and he goes through the specifications. Specifically, he had a product requirement specification and a detailed design specification. Now, the way you do this is you go through and you review the requirements spec and the design spec, basically any specs that you've got, section by section, and you check to see that there's a corresponding risk item. You should be able to capture traceability of the specification to a risk item. If you've got a specification element that doesn't correspond to a risk item, that's probably a hole in your risk analysis, because there's always a risk that something could go wrong. Now, some sections of the specification, like an introduction or something, may not map to a risk item, but the main body of the specification really should. So if you find any risk items that, or any specification elements that don't have risk items, you want to add a risk item for that. You want to capture traceability between the risk items and the specifications, and that's going to be helpful to you if/when the specifications change, and you can go through and rather than have to review all 100 to 200 risk items and see how the change to the specifications affects the risk items, you just look at the risk items that relate to that particular specification element. Now, it's not necessarily the case that every risk item has to map to a specification element. Every specification element should map to a risk item, or otherwise there's a hole, but sometimes you'll find risk items that don't necessarily map to specifications. Now, you could say, well, that's an issue where the specifications are incomplete, and that might very well be the case. Something you could escalate as a byproduct to project team to see if they want to address that. But you know, that's not unusual, and I wouldn't worry about it too terribly much. Just capture that fact that you've identified a risk that doesn't map to a specification and escalate that to the designers and business analysts and so forth. Now, map the risk items to the test cases. This is something you'll need to do if you do have an existing set of test cases. If you're working on a what's called a greenfield project where everything is brand new, then there won't be any existing test cases to map the risk to. But most of us have existing test cases, and you need to map the risk items to the test cases. And you know, you might very well find that there are risk items that don't have test cases for them, and if they're sufficiently high risk that they need to be tested, then that's potentially a problem. You need to add tests. Now, what you'll want to do is evaluate and reallocate your testing effort overall based on the level of risk, and I'll talk in a minute about how we did that. And then propagate the risk priority numbers of the risk items down into the test cases associated with them, and that's going to allow you to sequence your test cases, and also, again, if you have to triage them, then you'll be able to use that. Okay. Oops, pardon me. Got one slide ahead of myself there. Now, this is the effort allocation table.